comparing prices and budgets. So when we want to compare prices of a couple of different items, we basically just need to make sure that we're comparing like with like. So we need to make sure that we're looking at the same units. So price per kilogram or price per gram or price per metre or whatever. So the way all these things work is basically you just got to remember to get your fraction in the correct order. If anything goes wrong, that's usually it. So my unit price, my price per kilogram or my price per whatever it is, whatever units I want to use, is achieved by going the dollars. Think of the divide line as a per. So it's dollars per, in this case, quantity. So if I wanted dollars per kilo, I'd have my dollars on top and my quantity in kilograms in the bottom. If I put my quantity in grams, then what would come out would be dollars per gram. And so it's always the top thing per whatever's on the bottom. If I want my quantity in my price per metre, then I'd put my dollars on top and I'd be dividing by metres on the bottom, and so on. And this works the same for all maths, so it tends to be a common mistake. People will just get their fractions the wrong way around. So as long as you think of that bar in the minute, it's the, go backwards there. It's always the top thing, so it's this per that, whatever it is. Think about it like that. For example, when we do speed, it's kilometres per hour. So in the past, you would be familiar with those little triangles, the speed, distance, time thing we used to do. And we used to put distance, speed, time. So if it was the speed that I wanted, then I used to cover up the speed, and that left me with distance divided by time. Speed is generally measured as kilometres per hour. So when I did it, the distance was in kilometres and then the time was in hours. So when we did that distance divided by time, it was actually kilometres over hours, which meant kilometres per hour. If I put my distance in metres, then I'd get metres per hour. Or if I put my time in as, say, minutes, then I'd get kilometres per minute. And so on. If I actually wanted metres per minute, then I'd put metres on the top of my fraction and minutes on the bottom. And away you'd go. So that's the way that those work. I'll get rid of that. Budgets are the other part of this topic. So budgets are fairly self-explanatory. You're trying to work out whether you can save some money or whether you're going to wind up going into debt, whether you basically can afford the lifestyle that you have. So budgets have two components, income and expenditure, but they're broken down into smaller bits as well. Basically, if we look at budgets, income, take away expenditure, it's going to leave you with whatever savings you have, or surplus if you like. If you end up with a negative number, then you're actually going into debt. You're spending more than what you're earning, and therefore you're going to be going backwards. Income can include things like your actual wages. It can include any government allowances that you have. It can include interest that you've earned on bank details. It can include dividends from shares, and anything else. Basically, it might be rent on an investment home, whatever. So there can be a range of incomes, and we generally put those into a spreadsheet first and add all of those together. And then we'd subtract any of our expenditures. And expenditures are broken into three different types. So first of all, we've got what we call fixed expenditures. And they're expenditures that, as the name implies, do not change. So they're set things that don't vary in quantity or the frequency of payment. So it's things like rent. You're going to pay a set amount per week or per month, however your payments are set up. Phone plans, which are a set amount per month, those sorts of things. Then we've got variable expenditures. Variable expenditures are those which can't be avoided, but they might vary in their quantity. So for these ones, variable expenditures, it could be things like my fuel. I definitely need some fuel each week to get to work, but the amount of fuel that I use might change depending on where else I go. So that would be a variable expenditure. And then we've got things like discretionary expenditures. Now, the word discretionary means that there's some choice. So these expenditures are things that are irregular and they vary in amount and they are optional. So it might be things like my entertainment expenses. I don't have to go out, and so I can vary my entertainment expenditure, or my clothing allowance, anything like that. So they would be called discretionary. So you need to have your head around those a little bit. And if you're uncertain, justify an answer that you give in a test. Okay, let's do a few examples. So this is the CLUP Chapter 3 review questions. And we'll start, first of all, with some of the best buy ones, which is your unit pricing. So which is the best buy? So to compare it, we need to get the price per gram or the price per whatever. Now, these are all given in grams. So each of these are in grams. Watch, sometimes what they'll do is they'll give you some of your measurements in grams and some in kilograms, and so you might need to convert your measurements before you begin doing your divisions to make sure you get your final answer correct. In this case we don't, but the only other thing I'd be concerned about is that I'm probably going to wind up with very tiny numbers doing prices in grams. So sometimes we actually do prices per 100 grams or whatever, but I'll start with what they've given us and then we'll elaborate from there. So initially, if I want to do the comparison, it's always price over my units, my quantity. Probably quantity might have been a better choice of words. There, doesn't much matter, okay. So we're always going to be going price divided by quantity. So for the first one, my price is 95 cents. Now, don't just go 95, put it in dollars and cents because our next one is in dollars. So that would be one potential unit error. So 95 cents divided by the 145 grams, and that's going to give me, let's pop that into my calculator. That's going to give me, now watch this, in your calculator, what it's going to say? It's going to say 6.55172, yada, yada, yada. That's going to go on for a bit, and it's going to put an E with a -3. And people look at that and go, good Lord, I've got no idea what's going on. This is basically scientific notation. The negative means that I'm going, so this is the negative there, that means I'm going to make the number smaller, and I'm going to make it smaller by 3 places. So basically it just means that I move that decimal 1, 2, 3 places. So I'm going to wind up with an answer of 0.006 because I'm going to fill in these 2 places here with zeros. Now, and because I've put in my numbers in as dollars, and I've put in my quantity as grams, what's coming out is dollars per gram. So as a decimal, of course, what I'm really talking about here is 0.6 of a cent. So you can see I would need to take this out sometimes to quite a few decimals when I'm doing a comparison, and we'll check the next answer to see. I might need to go another decimal place or 2 to make my final comparison because there might not be very much difference at times. And this is one of the reasons why we sometimes would say, well, we might do it per hundreds of grams. And in that case, what I would have been dividing by in the bottom would have been 1.45. So I'll change my colour here. I could have done that from the outset and made that hundreds of grams. So dividing that initial number by would be 1.45 hundreds of grams. Or I can get this answer that I have got, which is my price per gram, and then times that by 100, which of course is then going to move my decimal 2 places this way to give me 0.6. So 6 cents per 100 grams. And so sometimes your questions will ask you to do that. We'll get back to the point here. We'll leave it as it is and we'll do the next one. So the next one, our price is $2.50. So I'd put my $2.50 on the top of my fraction and my quantity, which was 375 on the bottom. And again, I'm going to get a tiny number. So let's put this in. So 2.5 divided by the 375. Again, I'm going to get an answer with the E to the -3. And when I move my decimals, I'm going to wind up with 0.006 recurring, so I'm going to round that to 67. Now, if I want to now say, well, which is the better one? The better one is going to be this first one, not by much. You can see I'm going into, they've both got 006. 006 is their first 3 numbers, so it's the 4th number that I'm in fact looking at. If I change colours again, it's actually the 4th number that's determining it, and the smaller one was our first one. So my best buy is actually the 145 grams. Now let's do the next one. So the next one, we have 2 dozen cans so this one's going to be price per can for $15 or 16 cans for 10. So price always on top. So my dollars divided by, in this case, my cans. 2 dozen, a dozen is 12, so 2 dozen would be 24. So 15 divided by 24 gives me a price of 0.625, which is my dollars per can. If I did the next one, it's $10, and I'm going to divide that now by 16 cans. So 10 divided by 16 would again give me exactly the same answer, 0.625. So they're exactly identical. So in terms of which is the best buy, they're both exactly the same. Same if I was to do the next one. So I'm going to have $1.02, and I'm going to divide that by my 235. And for the second comparison, I'm going to have $1.71, and I'm going to divide that by my 395, and away we'll go. So let's check those. $1.02 divided by 235 is going to give you, again, I'm going to get that horrible E thing. So this answer here was 0.00434. The other one is going to give me 0.004329. So again, you know, they're both 0.4 of a cent. You really are almost splitting hairs. They both go all the way to a 0.43. So if I went here, I've got 0.43, 0.43. So it's the next place I'm looking at. So the cheaper one is going to be this second one, but there's not very much in it. That process is going to be the same for the next question. Watch in this next question that one of my units is given in kilos and one's given in grams. So I need to convert them both to the same. Doesn't matter which way around you go, whether you do them both in kilos or both in grams, as long as you do them the same. Personally, I'd probably go for the kilograms because the price per grams come out so tiny and you get all these decimals. So I'd probably go price per kilogram. So I'd have 32.50 divided by the 1.25 because that was already dollars and kilograms. So that would give me, let's pop that into my calculator, divided by 1.25. Gives me $26 per kilogram. For the second one, I'm going to have my 1565 is my dollars divided by my quantity. Now don't forget there's 1,000 grams in a kilogram. So I'm basically dividing that 600 by 1,000. 1,000 has 3 zeros, so therefore I'm moving that decimal 3 places, which would give me a quantity of 0.6 kilograms. So when I do that calculation, divided by 0.6, that would give me $26.08, taking it to 2 decimals. I'm a little bit squeezy there, aren't I? I might take that underneath. So that would have given me $26.08. So the first one was in fact slightly cheaper by about 8 cents per kilogram. Okay, if we did the next question, question 2, a particular brand of shampoo is available in 2 different sizes, 200 mils or 375 mils. So again, that's a straight up, and I'm not going to do all of these. Now that you've got the swing of it, I'll just step them up for you. So we would have gone $3.08 divided by the 200 mils, and that's going to give me dollars per mil. And for my comparison, I would have the $4 over 375 mils. So you're going to see which one's smaller and check that. But B, you might need to remember another skill. So on special, the smaller container of shampoo is reduced by 20%, and now which is the better buy? So the smaller container is the 200 one. To reduce something by 20%, hopefully you will remember that you'll need to use those multipliers. So I'd go take my 20 on 100, dividing by 100 is just turning that 20% into a decimal, which would be 0.2. So effectively, this whole thing is what we call a multiplier. And that multiplier would come out take 0.2 is 0.8. You need to be able to do some of these mentally, and people tend to panic when they've got decimals, but often it's easy to resolve by thinking of it as money. If I said to you, you'd hopefully be happy that, first of all, that 20 divided by 100, if I divide by 100, there's 2 decimals, so I'm moving my decimal 2 spots. If I said $1 take 20 cents, you'd very quickly tell me it's 80 cents. So often that whole issue with subtracting decimals, particularly if it was something like 14% or something that's, when you first look at it, is a little bit scarier for some people. If you think of it as dollars and cents, it's not, but if you think of it that way, often that makes the mental maths easier. People tend to be able to do financial calculations. So 0.8 times the original price is what we're doing. And the 200 mil price was 3.08. That would give you a new price, and you get that price and divide it by the original quantity. So I'll do that one quickly. So 0.8 times 3.08, that gives me a new price of $2.46. It's 464 is the whole thing. Given that we sometimes do transactions digitally, I might not round it, but typically, I'll accept it either way as long as you show you're working. Oopsies. Really, most of your answers should take it to dollars and cents because it is financial, but do watch that. Sometimes we don't round until the very end. So, and then over my quantity, which was 200 mils, and that's going to give me my price per mils. And then again, I'll be comparing it with the quantity for the other one over here. And then away you go. I had one other thought there, mental maths. Make sure you can do your mental maths. And the other option with this would have been just to find 20% and subtract it. So if you had to do it mentally, finding 20% is very simple. Hopefully you'll remember to find 10%, you're moving the decimal place one spot, so there's 10 lots of 10% in any number. So if my original price was $3.08, dividing that by 10 or moving my decimal one spot means that 10% would be basically 0.308 or basically 31 cents. So 20% would be double that, so I'm talking roughly 62 cents. And so I could have just gotten that price and take away 62 cents. So if you have to do it mentally, make sure you remember some of those strategies. All right, the next question, question 3. Salted peanuts can be purchased in 4 different sizes. In this case, we've got grams, 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 and more grams. So that should be a straight up get your dollars, divide it by quantity question. So we won't bother doing that one. Question 4. Car A travels at 495 kilometres and uses 50.7 litres of petrol, and car B travels 689 kilometres and uses 68.2 litres of petrol. So find the fuel consumption of each car based on kilometres travelled per litre and give your answer correct to 2 decimal places. So we basically want consumption per kilometre, so litres per kilometre, so we can work out which car is more efficient. So if I want litres per kilometre, I'm going to put my litres on top and my kilometres on the bottom, so it's litres per kilometre. So for the first car, for car A, we'd go 50.7 litres divided by their kilometres, so that's 50.7 divided by 495, and that's going to give me 0.10. I might take it to a few more decimals just in case I need to for the next one. So that's litres, so basically 0.1 of a litre per kilometre. For the second vehicle, I've got 68.2 litres divided by the 689 kilometres. So this is telling me litres per kilometre. So 68.2 divided by 689 will give me an answer of 0.09898. So you can see that the second car is slightly more fuel efficient. It's using less fuel than the first car. Now they seem to give this fuel consumption to the nearest 2 decimal places, and I did not actually do that in my final answer, so let's just complete that. So this would be 0.10. Hopefully you'll remember, if I'm rounding to 2 decimal places, then I'm checking the third decimal place to see whether I'd go up or down. If my third decimal was 5 or more, I'd round the second number up. If my third place is 4 or less, then I'm going to leave that second decimal as it is. So at the moment, I'm going to be leaving that as 0.1. For the second car, when I round that to 2 decimal places, I'm again checking the third decimal place. Now, it's higher than 5, so I need to round the second number up. But of course, in order to do that, what I'm going to have to do is round up the first decimal. So this one is actually to 2 decimal places is going to come up to a 0.10 because I'm going to round that 9 up to a 10 effectively. And so once you do that, we're actually having both the cars to 2 decimal places, both the cars have got equal fuel efficiency. If I took it beyond that, I'd be saying the second car is actually slightly more efficient. Find the fuel consumption of each car based on litres used per 100 kilometres. So at the moment we've got litres per kilometre. If I want it in litres per 100 of kilometres, then basically I'm just taking the original number that I got and I'm going to times it by 100, which will just move my decimal 2 places. So for the first car, so for car A, it'll be 10.24 to 2 decimal places. I should actually check my numbers to make sure I didn't round. I did round, that's okay. And for car B, if I get my original number and times it by 100, I'm going to again just move that decimal 2 spots. So I'd wind up with 9.99 to 2 decimals. When I take this to 2 decimals, I'm moving my decimal 2 places, and then I want 2 decimals after that. So I'm going to finish on this this number here, and so what I am looking at is this next number to check whether that 9 had to go up or down. Where am I going? 1, 2. I was looking, and I want to go to 2 decimals. Yeah, so I'm checking this one to see if I go up, and and I do need to take that up. So when I go do 2 decimals, what have I done? I've had a brain freeze moment. Let me fix that. So I'm going to rewrite the number and then show my working again, because I feel like I'm confusing you now. So I had 0.09898. When I move times it by 100, I wind up with 9.898, yada, yada, yada. But I want to stop this at 2 decimals. So I'm looking at the 3rd decimal, which is an 8, which means that I would move the one before it up. Now, because it's a 9, it means I actually need to move the one before that up. So I'd wind up with a final answer of 9.90 per 100 kilometres. And this is litres per 100 kilometres for both of these. And we should always show our units, so get into the habit of doing that. So again, as we originally said, car B is in fact more fuel efficient. And justifying it is the maths that we've done in the previous step. Okay, we might stop there.